All right. Good morning, everyone. My apologies for not being able to come to school today, as I'm not really feeling well and I am advised to stay at home. Nevertheless, our lesson would continue. And yesterday, I asked you to view the PowerPoint presentation and to complete the exercises. So, for this particular video, I am going to discuss with you the items found in the worksheet for your reference. And then, after doing this, I'd like you to work on the specific worksheet I'll be assigning you as well. Okay? So for this week, I'd like you to study independently, please, because next week I cannot anymore review this lesson. So we have to move forward with the lesson. All right? Let's proceed. So basically, if you studied the material yesterday, you would recall that our lesson was on geometric sequence. Okay? And geometric sequence comes in the form a sub n equal to the first term. By the way, a sub n being the nth term, okay, the term that we're looking for within the sequence, and we do not know yet the position of the term unless we specify the value of n. So again, the nth term is equal to the first term multiplied with the common ratio raised to the power of n minus 1. Now, what makes geometric different from arithmetic is in geometric sequence, we do have a common ratio. That means the progression is determined by a common number that is being multiplied to the previous term. And that ratio could be a whole number, could be greater than 1, or could be lesser than 1 as well. Okay. Now, there are some books who makes use of u instead of a. So we could also write this as u sub n equal to u sub 1 times r raised to n minus 1. Okay. So I think we are now ready to start with the lesson. So let's proceed with item number 1. So I'd like you to pause this video and try to review your answers. So if you are pretty sure of your answer, then you can play and try to see if we do have the same answer. Okay? So I think this one would be a lot better if you try to put it in a table because that would make this very organized. So here we are given that at the end of 2015, allow me to use E for end, B for beginning. So it's just shorter. So we have at the end of 2015, okay, the cost is actually $2.20. This is in dollars. All right. So and then the question is we wanted to find the cost at the end of 2019. Now, take note that prices, it's mentioned here, that prices rise at this particular rate, which is 2.65%. So, if you review the material, this is a sample of a percentage increase. Okay? Wherein the rise or the increase of 2.65% is the same as the original amount, which is 100%, added by another 2.65%, which gives you a total of 102.65%. Okay? However, we have to write this as a decimal or as a fraction. So you can either write it first as a fraction, which is 102.65% means per 100. And when you convert it into a decimal, this could be written as 1.0265. This is actually our rate. All right. When we say that that is our rate, that means at the end of 2016, to get the new amount, we have to multiply 2.20 by 1.0265, and so on and so forth. Take note that what we are looking for here is end of 2019. So what is the price or the cost at the end of 2019? Since both of them are end, so it's not really that confusing to work on. All right. So let's continue. Um, Here it's up to you which one you would consider the first term, or yeah, which one you would consider the first term. There are some books who considers this as their first term, while there are also some books who will consider this as the first term. Actually, it depends. Whichever you choose, you have to analyze and adjust. No, it depends on your preference. It depends on which makes this a lot easier for you to solve and analyze. You have to adjust. So if you go for this, that means within 2015 to 2019. So if you try, sorry, if you try to count it, we have to include 2015 in the count. Sorry, 15, 16, 17, 18, 19. So if we consider this as our first term, therefore our n is equal to 5. Because we have to include 2015 in the count. But if you wanted to start with 2016, because you might be saying that in 2015 that's the original, so I have to start at when the prices have already risen. So it's also okay. So if you try to consider the second one, the 2016, as your first term instead, so you have to start counting in 2016. So 2016, 17, 18, 19. So your n here is equal to 4. Okay, see, it's still the same. The result would still be the same because you do adjust. Okay, now in my case, I mostly comfortable using this. The reason is I don't have to compute for the value. Because if I have to use this, then I have to compute what this amount is. And that's another computation, something that I want to avoid. So you can explore if you wanted to, but for this particular solution, I'll have to use the data in 2015. All right? So I'll have to erase this. Sorry. Wait, let me just adjust my eraser. Okay. So I'll have to use the data in 2015 as my first term. So I have u sub 1 equal to 2.20. My n is equal to 1. And my rate, remember, it's 1.0265. And we are looking for a sub 5. Sorry. Let's be consistent with the variables. We're looking for u sub 5, which is your data in 2019. Okay, so we now use the formula. So we have u sub 5 is equal to our first term, which is 2.20, multiplied with our rate 1.0265, raised to the power of our n is 5, not 1, 5 minus 1. Here onwards, you don't have to do it manually because we can just make use of our calculator. So GDC, and then you will get u sub 5 equal to 2.44. And that's it. Okay? You may pause this video and copy notes if you need to. Sorry. This time, let's proceed to the second item. Same thing. Once again, pause this video and then copy down notes, or if not, compare your answers that of yesterday. All right. So I've assumed that you have already read this properly and accordingly, and maybe some of you might have answered this already in advance as well. So for number one, again, it's better for us to create a table because it makes things organized, no? Um, we are given here this particular amount, 15,000. Okay? And then each year, the materials depreciate by 12%. That means 15,000 is actually your original cost. Okay? So if we try to label it properly, 15,000 is the cost of the computer material, not on the first year, because take note, it's the original, but rather it's in year zero. Okay, let me use y for year and then the subscript as the number of years. So at year zero is your original, meaning at the beginning, when time has not started to move yet or to change yet. At year zero, the cost is 15,000. Okay? And we know that each succeeding year, the amount depreciate by 12%. Depreciate means decrease. That means from the starting amount of 100%, this will be decreased by a certain percentage which we are given as 12%. All right? That means each year, the remaining amount would now be 88%. This is now the remaining amount, and this becomes our rate. So we convert this into two forms, usually decimal, but if you find that difficult, you can start with a fraction, 88 over 100, which could just be written as 0.88. This becomes our rate. That means if you wanted to know the value of the material um, in year one, or at the end of of year zero, or in the next year, let's say in the next year, so that you won't be confused, year one. So we have to multiply 15,000 by the remaining amount, by the percentage, the remaining percentage, which is 0.88. Sorry. Okay. And this pattern continues. Okay. And that's it. So this is where your analysis comes in. All right. All right. So we are asked of 3 years, no? 3 years. So again, if you decide which of these values you would want to consider as your first term. So if I consider this as my first term, so I have to include this in the counting. So at the end of 3 years, my n is not 3, but rather my n is 4. Because I consider y sub 0, year 0. Okay? But if I would consider this as my first term instead, then we can normally use n equal to 3 years. It really depends on you, on your preference. In my case, and in this particular solution, I would want to choose the former, which is the original price, because I don't have to compute. So I just have to analyze. I just have to adjust my answers. Okay? So again, I'll use this as my first term. I'm sorry. I'll make use of that as my first term. So my n is 4. And then u sub 1 here would be equal to 15,000. And my rate is 0.88. Okay? So we are looking for the value at the end of 3 years. So end of 3 years, that means u sub 4 equal to the original value times we have the rate, and this rate will be raised to 4 minus 1 GDC. So your u sub 4 would now be equal to, so you have here 10,220. Usually if it's money, we write the entire thing, unless if there are a lot of zeros, so we can compress the zeros. But basically, if it's a money, it's better to write the entire value. Sorry. Let's proceed to part B. Find how many years it would take for the materials to be worth 5,000. So after how many years, no? So the thing here is, if you try, oh, again, pause this video first and try to go back to your solution, compare. If you're ready, then you may play this video. Okay, assuming that you're done already. So here, we are given already the value that we are looking for, which is this. Okay, this is actually the value at a particular time, and we don't know what that time is or what that year is. And that time or that year is the position of the term in the sequence. That means that's the value of our n. So this is now our u sub n. Okay? And this one, how many years? The number of years actually here serve as the position of the value or the term in the sequence. So this is our n, which is unknown. Take note that we already have our initial values on top. We have our a sub 1 and we have our rate. So we can just put in the values. So you have here um, 5,000, which is our u sub n, equal to our first term, which is 15,000, multiplied with our rate, and you have n minus 1. Okay, now before you do GDC here, it's better for us to do a little of solution, especially if the point in the IB exam is quite high. There are many points. Okay, so the examiner would wish to see a little of your solution before you use GDC. So we can divide both sides by 15,000. Sorry. And so we have here 1/3 equal to 0.88 and a power of n minus 1. So at this point, we can now make use of GDC. So the function we're going to make use of GDC here would be math and the numeric solver. Why numeric solver? Because we're only expecting one possible answer for n. We are not expecting many possible answers. Unless there could be many possible answers for n, then we can go for the other function, which is the polynomial solver. But again, since we're expecting only one possible answer, we just have to use the numeric solver. So to access numeric solver, go to math in your calculator, and then the last one, which is numeric solver, click it. Okay, and then in your numeric solver, this goes on the top box and the other on the bottom box. Then, after which, press graph. Graph is the key to click OK. So the box OK is aligned with graph. Click it. And then the answer is not yet, the value you see is not yet the answer. You have to click again graph, which means solve. Okay. And when you do so, you will actually get u sub n equal to 9.59 years. Now let's analyze. In this 9.59 years, take note that our first term, in this solution, I'm using my first term. I'm using 15,000. Okay, let me just highlight it. I'm using 15,000 as my first term, by which 15,000 is actually year 0. 15,000 is year 0. So year 0 is included in 9.59 years. Okay? That means we have to remove 1 year here because we have to remove the year 0. So, in other words, the material will be worth 5,000. Therefore, here GDC. Therefore, the material will be worth 5,000 after 8.59 years. Again, in 9.59, we include year 0. That's why we have to remove 1 year from that. And so we have 8.59 years. And that's it. You may pause this video and you may try to copy down some notes. Let's now proceed to the next item. Item number 30. Okay. So pause this video once more, and if you have answered this already, try to check your answers. And once you're done, you can play the video. So I trust that you have read this already. Again, it's better for us to put some table. The table would help you really to analyze it better. So here we are given at the beginning, sorry, at the beginning of 2019. Okay, let me use B for beginning. The number of people is 7.7. 7.7. Since it's billion, in a billion, or to come up with a billion, there must be 9 zeros. Okay? So we can write this as 7.7 times 10 power of 9. All right? And then it's also mentioned that the increase throughout the time period is 1.72%. So if you try to recall the previous items, the rate is not just 1.72, but it's actually 100% original, and this original has been increased by 1.72%, which gives us a total of 101.72%. So this is the one that we are going to multiply to get the increased value. But then we have to convert this into either a fraction or a decimal. So percent means per 100. Or as a decimal, we can write this as 1.010. One, oh, sorry. I'm so sorry. As a decimal, we can write this as 1.0172. Or as a rational number, rather, 1.0172. Okay? So if you try to analyze it, to get the next value, beginning of 2020, sorry, the value would be computed as 7.7 times 10 power of 9 times 1.0172, and so on. Okay? And that's it. So from here, I think this is already enough for us to answer the question. The question is, determine at the beginning of which year or at the end of which year when the population has doubled compared to the beginning of 2019. So beginning of which year or end of which year. So it's better for us to focus on the beginning. Anyways, when we already know the beginning of which year, then we could already analyze that beginning of which of the beginning of that year could be the end of the previous year. Okay, so let's focus on the beginning of which year. Okay, so in this case, again here the year serves as the position of the data or of the term in the sequence. That means we are actually looking for the end, the position at which year, which term in the sequence, in other words. And then we're given here that the population has doubled. That means we wanted to know which year when your population, which is your u sub n, is doubled. So you don't have to really compute it. You can just write it as 2 times 7.7 times 10 power of 9. All right? And then the rate here is 1.0172. Okay? So here we could already compute this one using the formula. So you have 2 times 7.7 times 10 power of 9 equal to 7.7 times 10 power of 9 raised to the rate times the rate 1.0172 raised to n minus 1. Do some math before you do GDC. Divide both sides by 7.7 times 10 power of 9. 7.7 times 10 power of 9. This gives us 2 equal to 1.0172 raised to n minus 1. Now, before we proceed, there's something that I'd like you to be particular in this particular solution. So that next time you don't have to have a very long solution. Try to analyze this part. Take note that we are looking for the year when the population is doubled. And when we simplify it, we end up with this. 2 equals to the rate, whatever the rate is, power raised to the power of n minus 1. 2 is a number to describe doubled. That means if the question was at what particular year will the population be tripled, do you really have to do the entire thing? Pause this video, analyze, or discuss with your seatmate. All right. So after your discussion, I hope that you're able to see a pattern. So if the question was tripled, basically we will end up with an equation of 3 equals 1.0172 times 10 power times n minus or raise 1.0172 raised to the power of n minus 1. If it was quadrupled, if it was 5 times, then you adjust accordingly. Okay, so this is actually a shortcut that you can use so that the next time you solve a similar problem, that you don't have to do the entire process. Okay, so when you do GDC here, again, we are just looking for one particular answer, so we can just directly use the numeric solver. Go ahead and solve it using your numeric solver, and you will end up with the answer n equal to 41.6. Okay? All right. So it's 41.6 including 2019. Take note, this is including 2019. Now, for us to analyze clearly, let's try to make use of a smaller number. What if n is 3? Let's use a smaller number. N is 3. So if n is 3, that means in which year will the population be doubled? In this particular value of the n, we do include 2019. So it's, if you try to count it, n equal to 3, 2019, that's count 1, 2020, that's count 2, 2021, that's count 3. In other words, if your n is 3, you just have to add 2 to 2019, or we just have to subtract 1 from 3, and that amount will be the one added to 2019. If you were confused, rewind my explanation. Okay, so in this case, 41.6, that means since we include 2019, for us to get the year, we have to add, we have to add 2019, not by 41.6, but rather by 40.6. Okay, and this gives us an answer of 2059.6. In other words, this happens within the year 2059. Okay, to make it safer, because at 2059, exactly at the beginning of 2059, beginning of 2059, the population is not yet doubled. It becomes doubled in the middle. So it's a lot safer to say population doubles, okay, at end of 2059. And this end of 2059 could be the beginning of the next year, beginning of 2060. So we say this is or, depending on what your reason is. Okay, and basically That's it. So that's the first part of my video. I'll be uploading the second part in a while. Thank you so much, everyone. And that's it.